3.2 goes over graphs of different polynomial functions. In 3.1, you looked at quadratic functions, so your power was 2. Today, you're going to be looking at more than just the second power. Some of them will be raised to the third power, fourth power, fifth, so on. With these graphs, you're also going to be looking at piecewise functions. So parts of different functions all put onto the same coordinate plane. The first part that we're going to look at is whether or not the line that's given to you is continuous. If the line continues, there's smooth, continuous curves happening here. So if you look at the graph on the left, that graph is continuous. However, the graph on the right, because it stops at one point, then picks up at another, there's a break in that line, so it's not continuous. For something like this, it is continuous because, again, there's no break in that line. There's no sharp movements happening. So another thing you have to look at is whether or not there's like a turn or a point within that line. If it's a sharp turn or a sharp point, then it's not continuous either. Everything has to be smooth and rounded within those curves. Something like this has that sharp turn, so this one is not continuous. For our first example, we are graphing this g of x is equal to the opposite of x cubed. For this one, I'm giving you ordered pair or x values of -2, -1, 0, 1, and 2. So with the -2, we are going to have the opposite of -2 cubed. -2 cubed is -8. The opposite of that is +8. Then for the -1, that's the opposite of -1 cubed. -1 cubed is -1 times -1 is a +1. Then for 0, the opposite of 0 cubed, that's just going to be 0, because 0 to any power is 0. Then the 1, we have the opposite of 1 cubed, so that's -1. And lastly, we have that 2, so the opposite of 2 cubed is going to give us -8. So these ordered pairs that we have are -2, +8, -1, +1, 0, 0, 1, -1, and 2, -8. So to graph this, the -2, 8, we're going to go to the left 2, up 8, plot the point. Then -1, +1, it's going to be here. 0, 0 is your origin. 1, -1 is here. And then 2, -8, we go to the right 2 and down 8. So this line you'll see ends up curving through your origin and continues to go. For our next example, we have h of x is equal to x cubed plus 1. We're working with x values of -2, -1, 0, 1, and 2. So with this one, we're going to have -2 cubed plus 1. The -2 cubed is -8, plus 1 is -7. Next, we have -1 cubed plus 1, so that's -1 plus 1, which is 0. Next, we have the 0 cubed plus 1, so that's 0 plus 1, which is just 1. Then we have 1 cubed plus 1, which is 1 plus 1, that's 2. Next, we have 2 cubed plus 1, which gives us 9. So we have ordered pairs here of -2, -7, -1, 0, 0, 1, 1, 2, and 2, 9. So on our coordinate plane, that -2, -7, we're going to go to the left 2, down 7. Watch your point. Then -1, 0 is on your x-axis. 0, 1 is on your y-axis. 1, 2, right 1, up 2. And then 2, 9, right 2, up 9. So this one actually curves to the right and continues to go up. For our next example, we're going to be working with k of x is equal to x minus 1 cubed. These x values that we have are -4, -2, 0, 2, and 4. So this -4 is going to give us -4 minus 1 cubed. That's going to give us -5 cubed, which is 25 times 5. It's going to give you a negative, and then it is 125. Then for the 2, we have -2 minus 1 cubed. So that's -3 cubed. That gives us -27. Next we have 0 minus 1 cubed. So that's -1 cubed, which is just -1. Then 2 minus 1 cubed, which is 1 cubed. That's +1. Lastly, 4 minus 1 cubed. The 4 minus 1 is 3. 3 cubed is 27. For this one, you see that you have a curve kind of happening between that -1 and that 1 for those y values. So another number that would be good to use here would be +1. And that would just give us 1 minus 1 cubed, which would be 0 cubed, and that's 0. We could also use 1 and -1, or -1 as well as 3. If you use the -1, that's going to be -1 minus 1, which is -2 cubed. That gives us -8. Then with the +3, 3 minus 1 is 2. 2 cubed is 8. So these ordered pairs that we're going to work with that actually go on this coordinate plane are going to be -1, -8, 0, -1, 1, 0, 1, we already have that one, 2, 1, 3, 8. So these are the ordered pairs that we're going to work with. So the -1, -8 is going to be down here. Then we have 0, -1, which is here. 1, 0, 2, 1, and then 3, 8. For the last part, you're using exactly what you used during 3.1. You're finding your domain, your range, your increase, your decrease, and your constant with all of these. Remember, your domain are the x values that are being covered by the line or lines on your coordinate plane. Your range are the y values that are being covered. Then your increase is from left to right, where is it going up, and what are those x values in which it's going up. Decrease, where is it going down from left to right, and what are those x values. And then constant is that flat horizontal part. And again, what are those x values? If we look at example A, you have 3 different graphs here. One that is your quadratic function, part of, one that's a horizontal line, and then one that's linear. For your domain, your x values that are being covered, look at where you're starting and stopping. That parabola is saying that it's continuing to go to the left, so it goes to -infinity. So we're going to put that down first. Then it goes to the right to -3, but it picks up at -3 on that horizontal line and goes to 4. That 4 for the x value ends up dropping there, so it just goes to +4. That's a closed circle, so we're going to put a bracket on it. And we're going to have a union of that linear function, which starts at 5 for the x value with an open circle on it. So it gets a parentheses, comma, it goes to the right continuously, so it goes to +infinity. Your range are the y values that are being covered. So here, let's do this. Your x values were from -infinity up to, 4, then goes to 5 to +infinity. Your y values that are being covered, you go from -infinity up to -5. However, it keeps going with the -5 on your parabola up to where? It goes past the horizontal line up to +infinity. So your range for this one is from -infinity to +infinity. Your increase is where it goes up from left to right, and the x values that it covers. So from left to right, it goes up from -6 to -3. And then both of those are going to get brackets on it. Then your decreases happen from the x values of -infinity up to -6, with a union from 5 to infinity. The 5 has an open circle on it, so it's going to get a parentheses. And that infinity does as well. Next, you have a constant at the x values of -3 to 4. Open circle on the -3, closed circle on the 4. So the -3 gets the parentheses, the 4 gets the bracket. For example B, you have 3 lines on this coordinate plane. So our domain are our x values. We go from -infinity up to -4. It stops there, but then picks up at -4, goes to 3, picks up at 3, goes to positive infinity. So your domain on this one is just from -infinity to positive infinity. Your range are the y values that are being covered. So for your range, you are going from -infinity up to -7. The line that's on the left picks up at that -7 because it goes to -infinity as well, with your y values up to 3. So it goes from -infinity up to 3, close circle on that 3, so bracket goes on that. And then we have it again at 6. So we're going to have a union with 6, and that 6 is included, so it has bracket around it. Next, for your increase, again, y values for your, x values for your increase. You're going up from left to right, from -infinity to, we said that was -4. Then your decrease happens, again, left to right. We're going from 3 to positive infinity. And then we have a constant between -4, open circle, so parentheses, and 3. Again, open circle on the 3, so parentheses. For your next example, for C, you have a graph that is for your domain coming from -infinity, going to that 3, and it picks up at 3 and goes to positive infinity. So your domain is just from -infinity to positive infinity. Your range, it is going from -infinity up to the highest point is 9. So from -infinity to 9, and that 9 gets a bracket on it. You are increasing or going up from left to right, from -infinity to -6. And then you're going down from -6 to -3. Oops. Get bracket on that. And then with the union between 3 to positive infinity. Lastly, you do have a constant between -3 and positive 3. The -3 is going to get the bracket. The positive 3 gets parentheses since there's an open circle on that one. For your last example, you see that there's no ordered pairs on this graph. So domain-wise, x values, you're going from -infinity to positive infinity. For your range, you are going from -infinity up to the highest value of 8. For your increase, you are increasing from -infinity up to -6. you are also increasing from -3 to +1. Is your decrease. So your decrease, again, from left to right, where is this going down? You're going from -6 to -3. And lastly, your constant is, again, that horizontal part, which we are going from 1 to +infinity. And then this -6 and this -3 should have brackets on it.